Hello everyone, and welcome to day number 25, scientific notation. So we've been working with exponents and properties of exponents. So today we're going to look at scientific notation, and this is just a way of writing very large numbers and very small numbers using scientific notation. Okay, so let's look at that. On day 25, the first page that you will see is you will have some numbers written in standard notation. You'll go ahead and have to drag and match the value in standard notation next to the value written in scientific notation. So let's just go over what that will look like, okay? All right. So you may get some examples that says 6 times 10 to the 4th power. So anytime you see a power and it's a positive exponent, you're going to move that number of places to the right, okay? So let's put our 6, our decimal at the end, and we're going to move 4 right because the exponent is 4. So here we place a decimal and we go 1, put a 0, 2, 3, and 4. So our number becomes 60,000, and that is what the answer would be. So 6 times 10 to the 4th power equals 60,000, okay? And you see it has 4 zeros. All right, in this example here, you have 1.35 times 10 to the negative 3rd power. So when it's negative, we're going to start at our decimal point and we're going to move 3 spaces to the left. So here we have 1.35. We start at our decimal, and because the exponent is negative 3, we're going to move 3 spaces left. So 1, put a 0, 2, put a 0, 3. So our number becomes 0.00135, okay? There we go. The next one is 4.571 times 10 to the 5th power. Because 5 is a positive exponent, we'll move 5 places right. So we'll write our number 4.571. Beginning at the decimal point, let's go 5 spaces to the right. 1, 2, 3, I have to add a 0, 4, another 0, 5. And our number, let's write this down, becomes 457,100, okay? The next one is 2.2 times 10 to the negative 2, so then we have to move 2 spaces to the left, beginning at the decimal point, 1, 2. So we have 0.022, and that is our answer, okay? And then the last one is 8.34 times 10 to the 3rd power. Our exponent is positive, so we'll move 3 spaces to the right. 8.34, beginning at our decimal point, 1, 2, add a 0, 3. And our answer becomes 1,340, okay? Okay, great. So let's move on to page number 2. And over here, it says to use the typing tool to fill in each white box in order to correctly rewrite the value in scientific notation. So here you have a number and you have something times 10 to a power. So we have to figure out what that is. So let me go ahead and do some sample problems with you, and then you can try that page on your own. Okay, so here we have a number. We're going to put our decimal point in between the first 2 non-zero numbers, which is 6 and 3. So put a decimal point there, and we're going to start counting to the right. 1, 2, 3, 4, 5, 6, 7. So written in scientific notation, 6.3 times 10 to the 7th power. Okay, now this example here, it begins with a decimal point. So we're going to go ahead on the right and put a decimal between our first two non-zero numbers, which is 5 and 1. And we're going to count going left until we get to the decimal point. 1, 2, 3, 4, 5. Since we counted 5 left, we are going to rewrite this as 5.14 times 10 to the negative 5th power. Okay, over here we have 15,000. We'll go ahead and put our decimal between the 1 and the 5 and count right. 1, 2, 3, 4. So written in scientific notation is 1.5 times 10 to the 4th power. Okay, down here is a decimal. So we're going to put our decimal point right after the 7 and count left. 1, 2, 3, 4, 5. So we would rewrite this as 7 times 10 to the negative 5. Here, put your decimal point in between the 2 and the 6 because they're the first two non-zero numbers and count right. 1, 2, 3, 4, 5, 6. So we would rewrite that as 2.617 times 10 to the 6th power. Here's a decimal. Put your decimal point between the 2 and the 2 and count left. 1, 2, 3, and we'll rewrite that as 2.2 times 10 to the negative 3. Okay? So let's go on to the next page, page number 3, and you'll have some word problems here, and you'll have to represent whatever that value is in either scientific or standard notation, depending on what they're asking for. And your answer choices are right on the right in yellow, and you'll drag and drop them into the correct white boxes as you figure them out. So let's look at some of those problems. And then real quickly on the last page, you're going to get some numbers either written in standard or scientific notation and figure out, is your answer choice A or B, or is it neither? So it could be A or B or neither, and then you would enter that in there, okay? So let's look at some problems and you can get started. Okay. The first word problem, Carlo bought tickets to a dance festival that 335,000 people are expected to attend. Represent this value in scientific notation. So we'll write out 335,000. We'll put a decimal in between the 3 and the 3. We'll count right. 1, 2, 3, 4, 5. And that will be rewritten as 3.35 times 10 to the 5th power. Okay, the next one is going to be, let's work on this one. During a science lab, Alex learned that the approximate radius of a grain of sand is 1.3 times 10 to the negative 4 inches. Represent this value in standard notation. So let's write out 1.3, and since it's a negative 4, we'll count 4 left. So 1, put a 0, 2, 3, 4. So written in standard notation, 0.00013. Okay. Michael went fishing, and the difference in weight between the first two fish he caught was 0.00053 grams. Represent this value in scientific notation. So let's write this here. Put a decimal in between the 5 and the 3, and because it's a decimal, we'll count left. 1, 2, 3, 4. And we will rewrite this as 5.3 times 10 to the negative 4. All right, scientists have discovered that the distance between Earth and Mars can be as close as 5.35 times 10 to the 7th power kilometers. Represent this value in standard notation. So 5.35, and the 7 is positive, so we'll count 7 right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And we'll go ahead and rewrite that. And here we have 53,500,000 as the answer. Okay, so go ahead and work on those problems, and I'll see you tomorrow in day number 26. Bye-bye.